Good morning, guys. Today I'm going to be talking about a very interesting topic that you're not going to find on YouTube or any blogs. I'm going to teach you how to combine semantic search with the power of Elasticsearch to develop powerful search engines. So essentially, with semantic search, now you can say, hey, I'm looking for something like this. It understands that and it would automatically query our petabyte scale Elasticsearch data and give you the relevant result. This is a very interesting, it's a hybrid solution. So let me show you a small demo and talk more about that. Okay, semantic search. Semantic search seeks to improve search accuracy by understanding the content of the search query in contrast to traditional search engines, which only finds document based on lexical matches. Semantic search can also find synonyms. This is really amazing. Now, so I want to show you a demo that I have. So I'll walk you over the code, right? But let me show you the data set. So this data set have been taken from Kaggle. As you can see, job posting data set. So this is where I have taken this data set from. Now I'll walk you over the architecture diagram, how you want to do things in production as well. But for now, let's see the action, right? This is beautiful, as I said. Okay, so I'm gonna remove the company. I just want to show you a title. So say, so I've trained on the job posting right now. So now I can say, hey, I am looking for software developer or developer in New York. So let's say I entered the search query, right? Let's see how it works on Elasticsearch. Look at this: Java software engineer, .NET senior developer, web developer. I mean, this is amazing. The power of semantic search and Elasticsearch, that's it, right? You can build extremely powerful search engines on your data that you have. So how I did all that, I'm just gonna give you a high level overview, and then I'll talk about some of the good practices we could do or how we could implement this in production, right? So I took the data set, right? I'm still cleaning up the code. I would try to put this entire code in the my blog section, so make sure to check that out. So I essentially, the first thing that I did is I downloaded the model, right, from the website. Once I did that, I essentially took the job posting data set. There's a job post, which is a string post, which has job description, salary, job title, everything, right? Now what I did is essentially I took a random batch of data, or random 500 sample. I made a class called tokenizer that can tokenize my string job posting. So then what I said is I essentially over here, as you can see, job post, I took all that and I applied a transformation. So what that happened is essentially that created essentially a vectors for the entire job post string. So now I did that. Now what I wanted to do is essentially I created an index on Elasticsearch with a KNN mapping right there. The dimension is 384 because my length of the vector is 384. The model that I'm using gives me a vector of size 384. I had to flatten the vector because you cannot use a dense vector on ELK. You have to flatten it out. So I did that. After I did that, then what I did is I uploaded the sample data set on Elasticsearch with the appropriate mapping. After I did that, then I'm saying that, hey, enter the input or search query. So the user is going to type job posting or whatever they are looking for. And then what I simply did is I convert that user, whatever they type, into a token or a vector. And then I pass that vector to my Elasticsearch KNN, right? I say, hey, give me all the items that are related to that vector and find the k is equal to 20 nearest neighbors on that. This is just a beginning. As I said, you could add tags. Now you could get so much relevant result. We could also implement a ranking system using a Lucene script, which means older the record, the less relevant they are. So we could do all that amazing thing on Elasticsearch as well. But this is, as I said, just a demo. So as you can see, I said, hey, I'm looking for software developer or a web developer in New York. The query, with the word embedding, it's so smart enough that it from the entire job posting, it knew that, okay, this guy is looking for software engineer or web developer. So PHP developer is also a web because they can develop websites using PHP. So it gave me that. So it's pretty smart, to be honest. And for example, let's say I am looking for chief I think I have a spelling mistake. Chief. Okay. Let's say I'm looking for chief financial officer in New York. So chief risk officer, chief accountant, secretary, junior, then we have some more recent senior consultant. So it's working pretty fine. And remember, this is my very first attempt, right? We could add tags and improve the search as well. So that's how you would do it. Now let's take a look at the architecture on how you would try to implement if you had to do this in production. So the way this would work is essentially the user will type a query like, hey, I'm looking for this, that, blah, blah, blah. That will go hit an API gateway. That will hit your microservice, a Lambda. The Lambda would pull the model from S3 and it would convert it into a word embedding. So the word embedding is created. Then the word embedding is passed through the Elasticsearch where the vectors are matched and the appropriate tags could be added on the bool section, or you could add similar. So you could also fuse this with essentially, okay, give me all the people that match my semantic search and filter out by a geolocation, this and that. So all that amazing, beautiful thing is possible with a hybrid solution, as I said. So you are essentially using Elasticsearch for performing searches and matching vectors, and you are using your word embedding model. So now tomorrow, if you want, so the only downside with this approach is, say you want to change your model, right? So if the model will emit essentially the length of the vector, it's not same what is defined on the Elasticsearch mapping. You gotta reindex all that data, which is a problem. But this problem you could overcome this problem with a second solution. What I'm about to propose is, so in this solution, what we did is we appended all the vectors as well on the index. So the second solution is to create an auxiliary index with just a job posting, and essentially grab keywords tokens and then pass through the main index that is storing the data. So now you form the query based on the similar item that you got from the auxiliary index, right? So that's that, but hope you have enjoyed this small walkthrough of semantic search and as I said, Elasticsearch, a hybrid solution that you could use for search engines. Let's try searching something else. Let's see, I am looking for an iOS developer or an Android. Let's see what it returns. Senior iOS. Wow, that's amazing. I never said to him that I need senior iOS. I just said I'm looking for iOS or Android. So it came senior iOS developer, senior iOS developer. So it's pretty interesting, right? The way this works. It's pretty fascinating to me, at least. As I said, you could filter out unrelated data using tags as well. So whatever user passes in the string, you could essentially then remove the stop words. You could, once you remove the stop words, then you could add all the keywords as a tag in the or section in the query in the Elasticsearch, iOS or developer, and then of course you can add the vector. So all these things, once you have your query properly, you can get really, really good results with that. So well, this is how you would use semantic search combined with Elasticsearch, right? You want to convert things into vector, then put the vectors on the Elasticsearch, and then you can perform matching on that. Well, hope you have enjoyed it. If you have any more questions on this, let me know. I don't think you will find these sort of contents on the internet. You might find something on Elasticsearch, maybe on semantic, but you won't find something that shows everything semantic, Elasticsearch from end to end, right? So yeah, hope you have enjoyed it. I'll try to make more and more videos on these sort of topics so a lot of people can use it. And remember guys, a lot of big companies are using similar techniques to do their searches, right? For example, I'm talking about Zillow or any big company that you see a website. They are using this technology. You can type fuzzy strings, and behind there's an NLP engine that understands that and then performs the vector matching and gives you the, for example, Amazon, right? When you say, hey, I'm looking for this, it tells you, hey, suggestion, right? Hey, are you interested in this, similar items, right? So all this is implemented this way essentially. All right, thank you so much for watching. Hope you have enjoyed it. If you have enjoyed it, do let me know in the comment section, and I would see you in the next video.